Alright, so this is 4.1 part 2. We're going to be graphing our quadratic functions today. So we went over this slide yesterday. It's super helpful to have this in front of you for all of our graphing stuff. So not only are we going to be graphing the parabola, we also are going to have to identify the vertex, the axis of symmetry, the domain, the range, and the max or min. So this slide is super helpful to have in front of you to help us identify everything we need. So let's go right into our graphing. So we can find the vertex, the axis of symmetry, and the domain without graphing anything. So our vertex form we know is a times x minus h squared plus k. So our vertex just comes from our h and our k in our vertex form. So we take this number h and our number k in our vertex form. The only thing is we have to change the sign of our h. So we change the sign of h. So what is our h here? What do you think? So h comes from inside the parentheses. Think inside the house. What is our h? -1, but we flipped the sign. So it becomes what? It's a positive 1. So that's our h, and then what's our k? What's our k? K is what's being added or subtracted outside, so what's being added or subtracted outside? 3. So our vertex is the point 1, 3. So we're going to go to our graph, we go to the right one and up 3. That's our vertex. Our axis of symmetry, the formula for axis of symmetry is x is equal to h. So it's always our x value in our vertex. So our axis of symmetry here is going to be x is equal to 1. So your axis of symmetry is always going to be that same number from the vertex. Just x is equal to the first number in your vertex. And our axis of symmetry is a dotted line through x is equal to 1, so we just put a dotted line right through our vertex. Axis of symmetry is always going to go directly down the middle of your vertex. Okay, and the last thing we can do without graphing anything else is our domain. What do you think our domain is here? So look back on that page with all of our vocab on it. What's our domain of any quadratic function? What's our domain? Awesome, all real numbers. So our domain is always going to be all real numbers. Every question we do with graphing is going to ask for the domain. That's a freebie question because the domain is always all real numbers. All right, next we need to graph before we find anything else. So we have one point on our graph. How do you think we find another point on our graph? So we've graphed things before in the past. What can we do to find another point? So think back to when we were graphing before in the last chapters. What was that? Not the slope. We're just looking for another point, so what can we do? We want to plug in a number. We can plug in anything. But we want to plug in something as close to the axis of symmetry as possible. So, axis of symmetry is at 1. What's a number really close to 1? 2. What's really close
0.
on the other side? 0. 0 would just be easier. We could definitely plug in 2. That would work. 0 would just be easier because it's less math. 0 is easier to work with. Smaller numbers to plug in are better. So, perfect. We're going to plug in 0. So we have -2 times 0 minus 1 squared plus 3. Now we want to solve this. So PEMDAS, what do we need to do first? What comes first for PEMDAS? What's the P in PEMDAS?
Multiply -2 times 0.
What's the P in PEMDAS? Parentheses. So we want to do the inside of the parentheses first. So we have -2. What's 0 minus 1? -1 squared plus 3. What comes next in PEMDAS? Exponents. So what is -1 squared? -1 times -1. Positive 1. So now we have -2 times +1 is what? -2 times 1. -2. And what's -2 plus 3? 1. So when we plugged in 0, we got 1. So one of the points on our graph is going to be at 0, 1. So we stay at 0, go up 1. Now the nice thing about parabolas is we have this axis of symmetry. That means that our graph is going to be symmetrical on both sides. So if we have a point that is 1 space away on the left side, we need that same point 1 space away on the right side. So our third point is going to be right there. So our graph has to be perfectly symmetrical on the axis of symmetry. So if we're 1 space away on the left, we need to be 1 space away on the right. Once we have our 3 points, we can just draw our parabola. So we have to have 3 points in order to draw our parabola, but once we got those, we're good. And we only needed to plug in 1 number to find our points. So we got our graph. Next thing, we need to figure out if we have a maximum or minimum. We're not going to have both, we only have 1. So is our vertex here at the maximum or at the minimum? It's at the maximum. Our vertex is at the tippy top of the parabola. So it's the maximum. So we can cross out the minimum. Our maximum value always comes from the y. So our maximum is 3. And then the last thing we need to do is find our range. Since it opens down from that slide before, we know if it opens downwards, our range goes from -infinity to our k, which is 3. So if you notice here, we only have 2 numbers really that we fill in all of these questions with. We have 1 that repeats here and here, and then we have 3 that repeats here, here, and here. Alright, so what's the graph of y is equal to x plus 3 squared minus 4? So again, our vertex form is a times x minus h squared plus k. Now you don't have to write the vertex form every single time, but I like to write it so you guys can easily see where that h is and where your k is. So our vertex is h comma k. So what's our h? But what do we have to remember to always do with our h? Change the sign. So it would be -3. So always have to change the sign of the h. And then what's our k? -4. So let's go ahead and graph our vertex. We go to the left 3 and down 4. Our axis of symmetry is x is equal to h. So x is equal to what? -3. And then we can find our domain before we graph. So what's our domain? All real numbers. Domain is always all real numbers. All right, now we can graph. So how do we find another point here? We don't always plug in 0. We want to plug in something as close to the axis of symmetry as possible. So what's something close to the axis of symmetry? If our axis of symmetry is -3, what's close to that? -2. So let's plug in -2. So we have -2 plus 3 squared minus 4. So with PEMDAS, what do we do first? The inside of the parentheses. So what's -2 plus 3? 1. So we have 1 squared minus 4. What's 1 squared? 1. And what is 1 minus 4? -3. So we plugged in -2 and got -3. So we're going to go to the left 2 and down 3. How do we find our third point? What do we do to find the third point? It's going to be on the left side. So since we're 1 space away on the right side, we need that same point 1 space away on the left side. Because our axis of symmetry means that our graph is symmetrical. So if we have something on the right, we need the same exact thing on the left. Once we have our 3 points, we can draw our parabola. Is our vertex at the maximum or minimum? It's the minimum. It's the lowest point on our graph. And what is our minimum value? Where does that number for the minimum come from? The y number. So what's our y? -4. So our minimum is -4. And then what would our range be if we open up? It would be -4 to positive infinity. So for the range, just make sure you go back to that page where it says whether it opens up or opens down, and then all you do is plug in that y number there, or that k. Any questions here? So let's look at the last question. So what is our h here? What do we have to do with our h? Change the sign. So it goes from a positive 7 to what? Negative 7. Kaylee, what's our k? So if k is what's being added or subtracted at the end, what's being added or subtracted at the end here? Negative 8. Perfect. So our vertex is at negative 7, negative 8. So that's going to be off of our graph a little bit here, but it's fine. What's our axis of symmetry? Daniel. So our axis of symmetry is x is equal to h. What's our h? Negative 7. So x is equal to negative 7. Our axis of symmetry always goes right through the center of our vertex. Brandon, what's our domain? All real numbers. All right, so Vanna, what do we need to do to find our next point? Well, we don't even have one point yet. We have 1 point on the line, but we need to find our second point. So what can we do to find that second point? Anybody remember? How do we find the next point? Plug in. What are we going to plug in here? Negative 6. We want to plug in something as close to the axis of symmetry as possible. So since our axis of symmetry is at negative 7, we want to plug in negative 6. So we have negative 3 times negative 6 plus 7 squared minus 8. Now we just follow PEMDAS. So what do we do first? Parentheses. So what's negative 6 plus 7? 1. So we have negative 3 times 1 squared minus 8. PEMDAS, so what do we do next? What do we do? Exponent. So what's 1 squared? 1. So negative 3 times 1 minus 8. PEMDAS, what do we do next? Multiplication. What's negative 3 times 1? Negative 3. And what's negative 3 minus 8? Negative 11. So we plugged in negative 6 and we got negative 11. So this is our next point here. So let's go to our graph. We go to the left 6 and down 11. So again, it's off of our graph, but that's fine. It'll be about right there. So now we have a point 1 space away on the right side. What's another point we have to have? We got 2 points. Where does our third point come from? We have one on the right, so we need one on the left. But it's the same thing on the left side, so it's going to be right there. Once we have our 3 points, we can draw our parabola. So I'm just going to connect our dots with our parabola. So we see our parabola opens down. Is our vertex at the maximum or the minimum? Max. It's at the highest value of our graph, so it's a maximum. What is our maximum value? Negative 8. Awesome. It always comes from the y, so it's negative 8. All right, and the last thing is our range. So what's our range going to be if it opens down? It opens down, so it would be negative infinity to negative 8. Any questions on graphing these?